years, NASA's shuttle fleet has launched a trio of spacecraft beginning a second phase of robotic exploration of our solar system. Initially sent to every planet except Pluto, their travels confirm planetary atmospheres reminiscent of early Earth. Evidence of water, active volcanoes, planetary rings, and even giant storms were discovered. The new phase of exploration provides even more in-depth studies. In October 1990, the Ulysses spacecraft began a 5-year journey. It was built by the European Space Agency to learn more about the Sun. Jupiter is the ultimate destination for NASA's Galileo spacecraft, launched in October 1989. After reaching the giant gaseous planet in late 1995, Galileo will deploy a tiny probe to penetrate the atmosphere and radio back data. At the same time, the main orbiter will use its complement of 12 experiments to study Jupiter's 16 moons, its atmosphere, radiation, and magnetic fields. Traveling to Jupiter requires a series of gravity assists, giving the spacecraft a push by visiting Venus once, then Earth twice before making the final leg to Jupiter. This is what Galileo saw when it recently came within 600 miles of Earth on its first pass. Hundreds of images were combined over a 25-hour period to give a view never seen before of the whole Earth in motion. Images of the moon were also taken, which include rare glimpses of its far side. Earth's sister planet Venus is similar in size, density, and position in the solar system, but very different in geology and climate, making it an important candidate for study. In May of 1989, the Atlantis shuttle crew released the spacecraft Magellan on a mission to map the entire surface of Venus. The elegant yet simple mapper carries one instrument, a high-resolution radar that sees through the planet's thick, cloud-choked atmosphere. Mapping has just begun at NASA's Jet Propulsion Laboratory in Pasadena, California. Investigators like Dr. Jim Head, a geologist at Brown University, are already seeing features that set this planet apart from all others.
The detail of the Magellan images and their crispness is so incredibly, these are just like pieces of art. You know, we sit and we look at these almost in awe.
Some raw data has also been processed into movies that bring out the desolate, lava-filled landscape making up so much of the Venusian surface. Old areas unspoiled by lava flows are intriguing to investigators because they show little sign of being eroded.
If you said to someone, gee, you know, we have this planet here that has this incredibly hot, dense atmosphere, and by the way, it sort of rains sulfuric acid and so on, you know, you get this vision of things eroding away completely and no record of anything. But it's quite to the contrary. In fact, the very dense atmosphere keeps the small projectiles that would come in from outer space off the surface, and the very high surface temperatures mean that there's no liquid water. And we're able to look at the surface and see in crisp, rich detail the nature of the geological processes that are operating, much more so than we're able to do on the Earth.
In the coming years, as the United States and its international partners continue planetary exploration, the spacecraft Ulysses, Galileo, and Magellan will play key roles, ultimately leading to a better understanding of our home planet.